Concrete is everywhere in our modern world. From statues to sidewalks, bridges to buildings, concrete plays an essential role in shaping the way we live. But how is it we trust a concrete parking deck to hold hundreds of cars when nearly every sidewalk is full of cracks?
The beams of a parking deck are made of concrete. But if they were made of only concrete, when subjected to heavy loads, the beams would bend and eventually break. In order to achieve the strength necessary to hold hundreds of cars, concrete undergoes a strengthening process known as pre-stressing. In order to pre-stress concrete members, these members must be precast. Precast simply means members are poured and dried in a production plant, then shipped out to the job site where they will be assembled into a structure. In the plant, concrete molds are anchored deep into the ground. Then, these metal cables, called strand, are pulled through the mold and fastened on one side using a chuck. The inner mechanism of the chuck holds onto the strand like a Chinese finger trap. The more the strand pulls away, the tighter the chuck holds on. This is perfect because the next step is to pull the other end of the strand with a hydraulic jack to approximately 34,000 pounds of tension force. The strands are then fastened by more chucks on the other side. With the strands in extreme tension, concrete is then poured into the mold. When the concrete dries, the ends of the strands are cut free from the chucks, and the member is lifted out of the mold by rebar lifting loops that have dried into the concrete. Upon removal of the mold, the member will now exhibit a slight upward bend in its shape. The strands, remember, are still pulled very tight within the concrete. The tightened strands pull the concrete at the bottom of the beam closer together, causing compression. The compression at the bottom of the beam causes the top of the beam to be in tension. The alternating tension and compression causes the beam to bend upward, a phenomenon known as camber. Camber creates an upward force in the member itself that will push against the downward force of weight as loads are placed on the beam. Thanks to camber, a pre-stressed concrete member is able to support more than 3 times the weight that a regular concrete beam can handle. The finished member is now ready to be shipped to a job site, where it will be assembled into structures we use every single day.
In addition to its strength, pre-stressed concrete is faster and cheaper to produce than other building materials like steel or masonry. These advantages and more will keep pre-stressed concrete a popular choice among structural engineers. So, expect pre-stressing to continue to support and shape the world around you for a long time to come.